8 physics, and today we'll be discussing light energy. That's another chapter, that's chapter 5, light energy. Okay, so what is light? Light is a form of energy that helps us to see things around us. So we can see things around us because of light energy, isn't it? So light is a form of energy which helps us to see things around us. And we'll be further discussing about light energy. Okay, so I am sure you remember what you have learned in class 7 regarding reflection of light. Okay, what is reflection of light? When a ray of light falls on any object, what happens? It bounces back, it reflects back. Okay, so when a ray of light falls on a very smooth and polished surface, it reflects back. Okay, so when it reflects back, that process, the phenomenon in which the light reflects back, is called reflection of light. So what happens during reflection of light? See, this is the medium. It's a polished surface, and say this is the mirror, and a ray of light comes from a source, and after that ray of light falls on the medium, it strikes the medium. It touches the medium and then it returns back in the same medium. Now the medium remains the same. Say this is a medium, here is your air. Okay, the medium is your air. So a ray of light comes from a source and then it hits a particle, say a window or a tile or anything else, okay, any smooth polished surface or a mirror, and it reflects back. This whole phenomenon is called reflection of light. Okay, and I'm just revising it about what you have learned in class 7. That is called reflection of light. So you discussed different types of reflection. You discussed about the incident ray, the reflected ray, normal, everything that is there in related to reflection of light. In class 8, we'll be talking about refraction of light. Okay, in class 7 you learned about reflection of light. In class 8 you will be talking about refraction of light. Okay, now refraction of light and reflection of light. The major difference is in refraction of light, there are 2 or more than 2 mediums involved. As I told you, reflection of light means when a ray of light falls on a surface and returns back in the same medium. That means the medium remains the same. If the medium is air, incident and reflected ray will be the same medium. If the medium is water, incident and reflected ray will be the same. But in case of refraction of light, what happens is, say a ray of light falls on a medium. Now you know that there are different types of medium depending upon the type of medium, transparent, translucent, opaque, isn't it? Now there are certain mediums which reflect some light and also allow some light to pass through there. So if a ray of light which falls on a surface passes through this medium, okay, passes through the medium, then how many mediums are involved here? 2 mediums. Okay, if it passes through the medium, if it passes, say this is your incident, right? It is coming and then it strikes the source or refracting surface, say mirror here or a glass. Let's not take mirror, let's take glass. Okay, I'm taking the medium as glass. Now if it strikes the glass, what happens? A part of it gets reflected back, a part of the ray will reflect back, but a part of the light will enter through the glass. So if a ray of light passes from one medium to another medium, then that phenomenon is called refraction of light. Okay, and refraction of light Now what happens is, you know that light travels with different speed in different medium. It travels fastest in vacuum or air and comparatively slower in water and glass, isn't it? So it depends upon the state of the object, which means air is in which form? Gas. So light travels faster in gases because the molecular arrangement. Then water, okay, the speed of the light decreases in water compared to gases or air, and then it will be the least when it's traveling through solid. So what are we taking here? Glass. Glass is a solid. So the speed of the light changes when it passes from one medium to another. Okay, and that phenomenon, when the ray of light passes from one medium to another medium, that phenomenon is called refraction of light. So here we have two mediums. One, air. A ray of light comes, falls on an object, and then refracts through the glass. So we have two mediums here. One is air, the other is glass. So when two mediums are involved, that is your refraction of light. So how do we define refraction of light? When a ray of light falls in a medium, falls on a source, okay, falls on an object and refracts to another medium, is called refraction of light. So that is the major difference between reflection and refraction. Reflection means when a ray of light falls back after being incident on a source, reflects back in the same medium. Whereas refraction means when a ray of light falls through a source and strikes an object and refracts back to another medium. So I hope you understood what is reflection and refraction. So reflection means when a ray of light goes back to the same medium, and refraction means when it passes from one medium to another medium. So today we will be discussing further more about refraction of light. Now as we were discussing that depending upon the medium, the speed of the light will be different. Okay, so the first case, depending upon the medium. The first case, what if a ray of light, falls from, or instead of falls, let me write, passes from, ray of light passes from rarer to denser medium. What happens when a ray of light passes from a rarer to denser medium? Now what do you mean by rarer and denser? So rarer medium means where the particles are less, and denser medium means where the particles are more. Example, air and glass. Air the particles are very much far apart, isn't it? So we say air is comparatively less denser than glass. Glass is in which form? Solid form, which means they have a lot of particles compact together. So we say glass is a denser medium because the particles are closer. Whereas in air, the particles are very much far apart. So we say air is a less denser medium. Okay, so we say air is a rarer medium and glass is a denser medium. So we have two mediums here. One is air, the other is glass. Now how do ray refract? How do a ray of light refract? A ray of light falls on a surface, comes from a source which is in the air, okay, and then falls on a refracting surface or any surface. Now, when it is passing from air to glass, what happens is the speed of the light decreases, okay, when it passes from rarer to denser, when a ray of light passes from rarer to denser, what happens? The speed of the light decreases. So it comes, and this is your normal. The line which is between the incident ray and the refracted ray is your normal. So this is your incident ray, and this is your refracted I don't know if it's clear or not. This is your refracted ray. Okay, this is your incident ray, and the ray which is passing in the glass medium, that is your refracted ray. And the dotted line that I've drawn here between the incident ray and the refracted ray is your normal. You know what normal are, isn't it? Normal is an imaginary line drawn between the incident ray and the refracted ray. So what happens when a ray of light passes from rarer to denser medium? When ray of light passes from rarer to denser medium, the speed of the light decreases and the refracted ray moves closer to the normal. Okay, it moves towards the normal, closer towards the normal. So here, that is your angle of incidence is more than angle of refraction. Okay, so what are the conditions here? When a ray of light passes from rarer to denser medium, the refracted ray moves towards the normal. The refracted ray moves towards the normal. And why do they move towards the normal? Because the speed decreases. Okay, let me give you an example. Say when you are passing through an open road where less people are walking, you can walk freely, isn't it? So what happens? You can increase your speed, then you can walk faster. But as you enter a very crowded place, naturally your speed decreases because there aren't spaces around for you to walk properly, isn't it? So when you walk from an open space to a crowded space, a crowded place, the speed of a person decreases. The same way, when a ray of light falls from a rarer to glass, that is from rarer medium to a denser medium, the speed of the light decreases and it moves closer towards the normal. Okay, it moves closer towards the normal. Now, set case 2, that is your second case. What if a ray of light passes from reverse, that is your denser medium to a rarer medium? Just the reverse, okay? That is what happens when a ray of light passes from denser to a rarer medium. So when a ray of light passes from denser to rarer medium, what happens? You can make it out from yourself only. When you move from a crowded place, when you are walking in a very crowded place, and then suddenly you just enter an open space, what will happen to your speed? Does it increase or decrease? It will increase because you can walk more freely, isn't it? The same way, for a ray of light, when it passes from denser medium, let's take glass here, to a rarer medium, say air. Okay, what happens is a ray of light falls on the surface and this is your normal. This is your incident ray. Now, where a ray of light falls on a surface, what will happen? Its speed increases and when the speed of the light increases, it moves away from the normal. So just the reverse of what was in the beginning, in the case 1. That is, what will happen? The refracted ray moves away from the normal. Okay, so this is your case 2. In the first case, when the ray of light falls from rarer to denser, the refracted ray moves towards the normal because their speed decreases. In case 2, just the reverse. When the ray of light falls from denser to rarer, the speed of the light increases and thus the refracted ray moves away from the normal. Okay, this is your second case. Now your third case. What happens if a ray of light is perpendicular to the surface? A ray of light is normal to the surface. Normal. What happens when a ray of light is normal to the surface? What do you mean normal? When the ray of light falls like this, that is, makes an angle of 90 degrees with the surface, straight. Okay. So when a ray of light is normal to the surface, so it doesn't matter whether it's passing from denser or rarer or rarer to denser. This is what normal means. So this is your incident ray. Now incident ray, your incident ray is falling normally on the surface. That which angle is it making? 90 degrees. So any ray which is normal to the refracting surface passes undeviated. So this is how the refracted ray will look like. It will pass undeviated. Okay, undeviated means it will not move away or apart or move towards or away from the normal. So this is your refracted ray. So when a ray of light is incident, when an incident ray is normal to the surface, the refracted ray will pass undeviated. Okay, the refracted ray will pass undeviated. Undeviated means it will not move away. It will just pass the same way it has come. So that is your 3 cases. Okay, so we learned about the 3 cases. Then we discussed about what refraction means. Refraction means when a ray of light passes from one medium to another medium. And then we discussed about the 3 cases. If ray of light passes from rarer to denser, the speed of the light decreases and it moves towards the normal. If ray of light passes from denser to rarer, the speed of the light increases and it moves away from the normal. And the third case, when the ray of light falls normally on the surface, then the refracted ray will be undeviated. Okay, so in the next class, we'll further discuss about what incident ray is, what refracted ray is, what normal is. So we'll stop till here for today. Thank you and have a good day.